topic is initial experience of biodegradable ASD occluder from animal to human. As we know, there are some potential complications of percutaneous closure of ASD by the popular and widely used nitinol device. As a matter of convenience to make future transseptal access possible for the patients after ASD closure procedure, we call for a new ideal device. First, let me introduce the PLLA biodegradable device. The framework is made of PLLA monofilament membrane, also PLLA fabric, and the suture made of PLLA, and the locker also PLLA monofilament, except the platinum markers cannot be degradable. PLLA biodegradable device made of the less, it is in the unlocked shape and locked shape. Let's see the video of a simulate procedure. Deploy the left disc to the septum, and then lock the shape in the right atrial. The PLLA, this material is a crystalline polymer. It gradually weakened of mechanical properties after 8 months implantation. Fully degrades in vivo in about 2 years. Finally, degradation procedure carbon dioxide and H2O. It has been used in coronary artery stent material. Previous study of PLLA, including tests for cytotoxicity and hemolysis and acute toxicity and muscle implant, showed good biocompatibility and safety. This is a persist of PLLA degradation. The molecular weight of PLLA monofilament remaining in vitro is almost the same as that after implantation at 9 months. The PLLA monofilament is almost disappeared among about 50 days in the speed up degradation in vitro. According to the linear relationship, the fully degradation is about 6.5 to 9 years after implantation. This was the device for percutaneous closure of ASD in swine model. ASD model's creation. This angiogram showing the atrial septum, transseptal needle puncture, and angiography confirming left atrial through ASD and balloon dilation, the defect. TTE showing the ASD. This we deploy the device. After deployment, have the TTE monitoring. Animal study results after 6 months implantation and 1 year and 2 year follow-up. We can say the compare group nitinol occluder at 1 month. This is the biodegradable occluder. At 3 months, the right atrial disc was mostly covered with new tissue, with the exception of the locking piece. This is the cross anatomy, nitinol occluder and biodegradable occluder in different time after implantation. Radiography and TTE and microscopy studies demonstrate that PLLA device was positioned well with no shifting murine thrombus formation or atrioventricular valve insufficiency. Historical evaluation showed that the PLLA devices were partially degraded in follow-up study. ASD closure with the PLLA biodegradable device in swine model is safe and effective. This study, the article has been published in the Journal of CCI in September this year. And then we have launched the multi-center clinical trial in August, including 11 centers in China had the clinical trial. This is the registration information of clinical trial in FDA and CFDA, the public website. Percutaneous implantation of biodegradable occluder in humans. In recent 3 months, we have the device implanted in 11 patients, and 6 males and 5 females. Age is 3.2 to 26 years. This patient selection larger than 3 years and 10 kilograms in weight. Central secundum ASD with a left to right shunt that are of the hemodynamic significance. Patient indicated for ASD closure have clinical evidence of right ventricular valve overload. This table demonstrates the clinical characters of the 11 subjects who underwent the transcatheter closure ASD with Epsilon trademark ASD closure device. The results demonstrate the immediate restitution in 3 cases. No procedural complications related to the device or delivery systems. No arrhythmia or atrial ventricular block. Follow-up results, all of the subjects were available for follow-up. 1 month finished in 7 cases. 3 months follow-up finished in 5 cases. No arrhythmia or atrial new occurred atrial ventricular valvular insufficiency. This is the table show the echo follow-up. The first case is the secundum ASD. This 16 millimeter QPQRs was 1.6. The absorbable ASD closure system with a 12 French long sheet detachable sheet and the 24 millimeter bioabsorbable occluder. The device cannot be seen fully in the X-ray. We can see the 7 markers in the screen. 1 marker on the tip, and there are 2 markers on left this and base marker, and right this total 7 markers. But in the echo, we can see it clear. This. We can see a device is in good location and shape of occluder, no residual shunt. After deployment, the TTE monitoring. This case, there are small residual shunt at 3 months follow-up. And a 10th case is a female. With a 9 French sheet and 12 millimeter biodegradable device. The biodegradable occluder was well positioned before deployment. The occluder rotates, but when we try to release the device, the occluder rotates with the cable when attempting to complete detachment. We can see in the echo, the occluder was inadequate person on the TE monitoring. The occluder was retrieved and replaced by a same-size device. And then the device deployed at second attempt. The occluder was positioned well with excellent conformability to anatomy. The follow-up, and the 11th case is an adult patient. We use the TTE monitor, and we can see the secundum ASD about 20 millimeter. Biodegradable occluder 26 millimeter with 14 French sheet. TE monitoring. The device was successful retrieved because when we during implantation, the left is pressed into the right atrium. Because the material is soft than the nitinol. And then we change a larger device.
Professor Xie, maybe with the interest of time, maybe you can wrap up.
Okay, thank you.
Thank you.
You can see the follow-up. Okay, the real-time 3D TEE and TTE monitoring. Further result, although the short-term effect is satisfactory, but the long-term follow-up study is necessary and validated by multi-center clinical trials. Development of radiopathic biodegradable device. This is our team. Thank